and you took it home, and it's hands-on. You also had Fignition, which is an 8-bit computer that you can solder together, and kids were really excited about that, really involved with it. So then we thought, well, why don't we unpack Arduino so that it has all of those features? So this is a breadboard layout for the Arduino, or it's Arduino compatible. It's the same as an Arduino Uno, thinks it's an Arduino Uno. But we've spent a long time trying to find the cheapest possible way of tackling this, so that you pretty much just get the good stuff from the AppMega chip itself. So all of the Arduino pins are there. It's got the Arduino bootloader on it. It just thinks it's an Arduino. So you program it in C, or you can control it from Python. And so that way you can knock up some kind of a project. But so what's the focus of what we're doing? We're basically workshopping with people, we're documenting. So we figure out what it is that people can do and what it is that's natural for people to do, easy, fun, so on. And then we try and backfill that with lots of documentation so that teachers, hackspaces can pick it up and run with it. So when we're designing a particular project, what we're aiming to do is maximise possible futures. I'll give you some examples. They're around really anticipating other people's stress. So what kind of things are going to be the blocker for them when they pick it up? Well, you could easily, for a given project, start using the power rails. If you don't need to use the power rails, then what you'll end up with is a layout that works exactly the same on a 170-point breadboard or on Stripboard. So if you're talking with teachers or with kids, you can just have a single diagram that means they go, oh, right, I've made that, it works. Now I'm just going to move it onto this other cheaper thing, or I'm going to solve it together, it's just the same. There's no need for them to figure out through a schematic what needs to be replaced and how you substitute this. The other thing is to try and think in terms of progression. So this case is a paints in the air. So you see a picture in a minute. Should have wrote it down. Yeah, paints in the air. So you've got yourself one LED when you flash it to start with, but then why not get 8 LEDs and control them in a structured way so that it paints in the air? And then move on to a stripboard system. So these things are things where you can kind of lay out the steps so that they're straightforward for people to progress with. And if you are an electronics engineer, you're probably in the best position to anticipate that. And most electronics engineers, my experience looking on the web, projects they document, they're assuming it's other electronics engineers going to pick it up. So they let everything hang out, and all of the complexity is still there. It doesn't need to be. It's actually not that much harder to just do a little bit of extra work and make it straightforward for people. So, don't do electronics. Another manifesto plan. Okay, so we are doing electronics, but we're not really. We're doing projects. So the point is, it does something. Why do you want to learn electronics? Why do you want to learn software? It's because you can get your name to paint in the air. And that's something you can take home to your family, to your friends, and say, look, I made it. Rather than, what did you do today? Oh, we did software. What's that? Well, I don't know. That's what happens otherwise, basically. So, projects. Let's have bathroom fans that are fast triggered, right? You know, that's something that kids can get their teeth into. You have got the fundamentals of inputs and outputs, and people will figure out sensors and actuators and how to build circuits. But it's not just about this kind of stripboard hack where I did this and I did that. This is, by the way, a nice stripboard hack, where you have LEDs on the top and buttons flipped over on the bottom, so you can get backlit LEDs that way. But turn it into something which people can easily construct from a bag of bits, which is something that we've been doing. You can source your own. We've got all the information online. If you want to buy stuff for your hackspace, buy 50 of them. Don't buy them from us. Yeah, starting with Blink, get to something which does something fancy. It's a project. You can see why you're involved with it. And another thing, well, actually we subtly make problems for people, and we don't solve them necessarily. And the reason is they're supposed to be learning prototyping. So these are tools that create opportunities for them to invent their own thing. They'll only be able to do that if they've actually been exposed to some of the important steps. So what's wrong here? This is an Adafruit circuit. It's a persistent division circuit, funnily enough. The only problem is, well, it's not that easy to reprogram it, actually, because you need to have a special device, which doesn't come with it. $17.50, I think it is. You don't get the device to reprogram it, so it will paint what they wanted you to paint. until you buy one of those unusual devices. And you can't really make it turn into anything else because it's got no spare points to attach things to. So you're stuck. So we spent a long time with a diatribe really about why we're not doing PCBs. You know, why don't we provide people with the shrimp already made? Because that would be good, wouldn't it? Well, yeah, and there's lots of people doing that. Cheap Arduinos are out there. But if you want to build an Arduino and along the way learn what it takes to build an Arduino, which one's pin 1, how does a breadboard work? You know, that kind of thing. So I do take issue sometimes with what people are learning. And if you're sitting down and you're soldering a circuit that somebody else has designed, somebody else has done all the layout, has done all the thinking, and then, you know, how different is that from what these guys do all day? You know, if we're going to look at UK PLC, the knowledge economy, the creative economy, we need to empower people to do stuff themselves. So we don't preload the chips. That's because it'd be easy to send you a kit which has got the program on it already. But then you don't see the IDE, you don't see the code. In the context of the persistent division, for example, all the font information is in there. So you can dig in there and go, oh right, so that font, I could change that, copy and paste that, so now it's got a different pixel font. Or you could design your own icons, a great reason to learn binary. So you start constructing your own bytes, type those numbers in with columns in the right part of the code, and then you're painting your own icon that you've designed with felt tip pen on a piece of graph paper. And stuff like this, which is almost not documented at all, right? Get a coin, put it in Coke, cleans it off nicely, then solder it between 2 pieces of stripboard, and then you can control the pull-up resistors and software here, and make 4 buttons, so you can build your own tilt switch for 1 penny plus stripboard. Another thing that's really fundamental to what we're doing, lead from behind. One thing that people very often say to us in this context is, this isn't new, you know, people have been doing this for years. Absolutely. That's what we're relying on. That's because there's lots of good documentation out there, there's great ways of doing it, there's lots of different ways of doing it, and we're curating that, documenting it and consolidating it to something that regular people can use. They will eventually become electronics engineers probably, or software engineers probably, but you don't have to start there. So we're drawing on what's out there. We're not the guru of anything. It's much more like a great economy of people doing stuff. And I'm one of the ants at best. So just as an example, anybody know what that is? Nobody in the audience. I got quiet once, somebody did know. That is a form of ancient Chinese currency. So, of that time, and for those people, that was an extremely valuable thing. And the thing is, we don't see that value because we're not there. So, understanding what that value is involves opening things up to them and listening to them. And here is a classic case of that, which is that somebody's just gone off and built a PCB anyway, and it's brilliant, and he's there. So, you know, right up all the stuff about wiring PCBs. Well, what he's done is he's documented it so that other people can do it themselves. He's not providing the PCB, he's providing you the means of figuring out how to make a PCB, which is a whole different story. So, well done, thank you. And well done to Art Squire and the co-author, where's his name? Co-author of the Arduino cookbook, Packing Shrimps in London Hackspace.
The main author. He's the main author.
The main author. Okay, thank you. And you know, people figuring out how to do it with surface mount components on stripboard, which doesn't surprise me. People not bothering with any kind of stripboard at all, or pencil or anything. And you know, that's somewhat elegant. This is just solder it on the chip. Why not? And then you can move it around between both boards. But we've also got kind of weird spin-offs like, not weird, brilliant spin-offs, like the shrimp bot. And this is, I don't know, it's an interesting thing is that people are taking the name and they're just using it, and we're kind of okay about that, in that that's a shrimp bot. I've since built a robot, and I can't call it a shrimp bot because somebody's already built it, and that's fine, you know. And so Geek Moore's built a shrimp bot. He's working in Accrington Stanley with kids, making robots move around with Python and C. We've got people like Embecosm with maybe aliens somewhere around, and they're knocking together weather stations based on the trip. And again, there's a lot of craft and design things there. It's not just about the software or the electronics, and it becomes a project rather than merely an experiment. And this is lovely, fairly new development. The shrimp key, so it's a makey that's built on a shrimp. And I'm working with Sjoerd to sort of turn that into a breadboard version. It's right here. I might even get a demo of that before the end of the session. It's never really worked before, so I've never tried it, so we'll have to see. So, fundamentals of what we're looking at. It's anticipated motion. So figure out how something is going to have, what experience somebody's going to have when following along with your project or picking up what you're doing. And it can very often be easy to make it a bit more accessible, maybe change some of the words, maybe give them put some extra effort into finding where regular people can buy things, if you're buying things from unusual or specialist places. Maximise possible futures. Don't just think about your own getting it working. Oh, now it's working, that's fine, I'll tweet it and that's it. Think in terms of, oh, okay, I could just spend a little bit longer on it, and then lots of people can reuse it in lots of ways, as has happened with our project. I'm really pleased to see it. Leave from behind. It's got to be other people that tell us what to do, because we've hardly any idea what to do. And make problems. So create opportunities for people to solve things by actual contact with the prototyping steps, because that's how they will learn prototyping. And then focus on projects rather than electronics and software. There's a tendency towards, in science, in STEM subjects, an alienating educational model, which is around deferred gratification. So if you learn this, if you just spend the next 7 years of your life learning math, eventually you'll realise why it's useful and you'll get a job probably. And that works for some people. There's a whole lot of people for whom that is the turn-off, that's the reason they don't do it. So think in terms of projects, think in terms of getting good stuff out. Futures, quite a lot of futures possibly, because we're getting a lot of contact from people. And one thing that we want to do just internally to our own project is probably move into documenting the soldering builds a bit more. They exist, but they're not documented. So if you're interested in doing soldering workshops with Stripboard, then you can take our vector art and have a crack at some of the things we've been doing. There's Internet of Things and Bluetooth and two-wheel robots and so various other things happening. This is quite nice. It's a £6 Ethernet shield, I think, with a shrimp, and it builds a web server, and it's pretty easy to do. So thank you very much. I'm going to try a demo whilst questions come in, if that's all right.
Round of applause, please. And while the demo is being assembled, if anybody has a question, pop a hand up, I will race around the microphone. Well, not race, walk gently.
Cefn, the point you made right at the beginning about the schools keeping them in a box because they're too expensive is absolutely what drives us as well. Because stuff's got to be down in the £1, £2 bracket before you can give it away or allow them to blow up half a dozen learning.
Yeah.
Could you just talk us through the whole cost? Because I need to make a huge amount of work on this. And although the 80 mega costs less than £2 and the capacitors and so forth cost nothing, you've got the breadboards, the battery boxes, that programmer. Could you just talk us through the strategy you can do to take those costs out? Because those can swamp the cost of the actual shrimp.
Yeah, so a typical target for the information that we're providing online in terms of cost is a classroom. So the numbers we're tending towards are like 20, 30, or a hack space. In terms of, we're buying them in the hundreds at a time, or heading towards thousands at a time. So you can get about 30, 50 for about the prices that we're getting them. And that's all documented online. This is the little shrimp, by the way. And Claire from Shrimping It as well. So that means that you can afford to get stuff FedExed from China. pretty much. That's the key point at which things start to become feasible. AliExpress and Alibaba in more in bigger volumes. Alibaba, for example, doesn't list any prices. You go and talk to them. Would be a way of buying. We get, for example, 170-point breadboards for 60p. We get the larger breadboard for £1. That's the 400 points. We've worked with Beta to get the DTR pin soldered onto their CP2102. It's a much cheaper alternative than the FTDI, which people have been using. They are now shipping the new CP2102 and 2104 with the DTR pin soldered on. You need that so that the reset signal can get sent through to the Arduino, and so it will program properly. So, I'm suspicious that it won't. It's been flying around in the bag. Let's try. No.
Any more questions while we're
Yes, more
tweaking
questions.
the
So,
demo?
did I answer your question adequately?
Yeah, it's an ongoing conversation. I just wanted to hear your latest thoughts on that, because I'd love to give our local school
Yes.
a shrimp for every kid.
Yes.
And at £2 I could afford to do it. But they've got 1,200 kids there, and for it to be useful, they've got to be able to take it home and get the whole thing working.
Yeah.
And it's those bits around the outside are the killer.
If you can go towards soldering onto stripboard, we've got, I think the cheapest that we've deployed is £2, was it £2.65? So it's getting towards that point. The modules, new art modules are now I think 120. So that you can reuse those because you only need to program something and then it can run off batteries, for example. So in principle you could give a whole class soldered shrimp for about $2.65 each. And then, and from there you can have them share a programmer, and that means that you can get those numbers very, very low if you need to. But then at the same time, it's quite useful for them to all have a program because then they can take it home and then they can.
That's what you want to get. I just wanted to hear what your latest thinking was.
But anyone who's interested in sourcing stuff, we're managing this information actively. You might find stuff out, tell us, but equally well, if you've got a particular group you want to buy for, get in touch and we can send you everything we've got. So, yeah. Sorry.
Has anybody done any work already, or is it worthwhile doing any work and trying to port Arduino onto some of the smaller devices, the Tiny, for instance?
That's already been done. So there are cores for that. So the Arduino software can have extra modules kind of thrown into key directories, which gives it the information it needs to send code to that type of chip. So that's been done. The reason you don't go down that route is the complexity of managing it. So actually in the context of a school where you're working closely with them, you might be able to drive down the costs there as well. But from the situation that we're working with often, where people might be at home and they're like, okay, I've downloaded Arduino, now what do I do? Oh well, there's a whole series of complex things that can get quite badly wrong, versus just hit go. You know, that's the contrast that we're having. So there is a trade-off. We've gone with Arduino compatibility straight down the line because that gives lots of other projects as well. The other angle, other people's projects that work on Arduino will go straight onto this.
Yeah.
Whereas if it's in, if you're trying to get it onto an 18 Tiny, you'll find lots of things aren't quite the same.
And
Thanks.
the 3 to 8s are actually cheaper. The Tinies aren't that much cheaper because they sell so many 3 to 8s with all the Arduino stuff.
Actually,
they're often cheaper than the Tinies.
that's what I suspected, actually.
That's value that is, yeah. So keep the question going. I don't know how many more minutes I've got, by the way.
You've got 8 minutes left.
8 minutes, oh God, well, this was working this morning for the first time. So let me talk you through the basics. What we have here is a battery, a button with a pull-up resistor, which is connected to ground. That might explain something. No, it's not. So yeah, with a pull-up resistor, and the aim is a regular battery. It's pulled up to 5 volts through a pull-up resistor, unless you connect it straight to 0 through a button. You connect that pin straight to 0 through a button, which dominates the signal that's coming through the resistor. So the resistor is there to pull it up to 5, give it a clear, I'm not being pushed signal, until you connect it to 0, at which point it goes to 0. So what the makey people have done is figured out that, well, we're kind of a bit like a button. We're just a very, very resistive button. So if we just have a very big pull-up resistor, then we can use the human being as a much less resistive element. And then, so you become the button. So the idea is to attach this thing to your wrist, and then anything you touch, you make the circuit. But yeah, as I say, it was working this morning, but it might not be working right now. We've had some. It's interesting that the interactions across, well, the globe really. You'll see the Shunt It map online. There's people everywhere, right across the US, and this project, the Shunt Key thing, is from the Netherlands. He's been workshopping there with it. So we're in touch trying to figure it out. You're welcome to join in if you want to build some. Probably try and get it working for tomorrow. I've got maybe 20 or 30 kits worth of bits that people want. But the kit for this particular case is about 20 resistors and 2 Zener diodes. And that's it. Unless you want fancy crocodile bits. So that's a really nice project right there in principle. Compared to a makey, $45. I guess the resistors and diodes less than 30p, less than 20 probably. So, any other questions? Right then, so I'm going to get into dmessage, see if I can see what it's doing, whether it appears or not. So the point of this is that it's pretending to be USB by, I think, bit banging some wires. So we just wired in directly to the Atmega. And then it's pulsing as if it was a USB device, certain wires. The diodes are in there to cope with the fact that this is running at 5 volts, which is, again, a convenience because plugging stuff into USB, running it off of certain batteries is more straightforward. We could switch it round so that it ran at 3 volts or something, but it just makes things more complicated. So we've got Zener diodes that have stepped down from 5 to 3.3 volts. So it's appeared. Do you think that would be good? So then, oh yeah, it does work, okay. So that's now sending keys. Okay. Hey, you can hold this. So, hopefully this will also work. Yeah, that works, okay. Now, I need some tin foil. This is Sjoerd's idea from the Netherlands. So I was like, how do you get those anti-static wrist straps much cheaper? Tin foil. There we go. I'm hairy, I don't know if that makes a difference. You wouldn't know. Oh, hang on. Yeah, maybe get the green one and put that. Put those two together. Okay then. It works. Right then, so hopefully we should be able to. Yeah. Okay. That's literally the first time it's ever worked. Apart from the button, which is what I tested it with. So I do act as a good button. Anyone got any fruit? That's the best way of doing it. Any fruit in the house? Have you got a lime? Okay then. So at the moment it's only geared up for one button, but it can have 16 independent. Oh, we've got an orange. So this is the classic way of doing it. Might destroy your orange a little bit, is that alright? Yep, still working. So, no, stop. Alright. So, there we go, it worked. My hairy arm. So, I'm well happy to take any more questions if I've got time, but I should get shifting. Yes?
We've got time for 1 or 2 more questions.
I heard somewhere that it is possible to have the Arduino itself be like the ETDI without having the ETDI or the other one that you just mentioned. And
yes.
If so, is it possible to make it even cheaper and have it be programmed that way instead, so that the Arduino is doing it
At the moment, our shrimps cost more than the UARTs do. The UARTs are about 120, which is just the price of the chip alone, of the mega chip alone. So I can see how that could work if it tipped the other way. You know, if shrimps were cheaper than the UARTs, which is the serial part, serial communications module, this thing. Then that would work. And it is feasible. When we bootload the chips originally, we bootload them with another Arduino or another shrimp, same thing. And you can, when you bootload them, you can, as you were telling me earlier on, you can. You've got the documentation. Is it Sheffield Hackspace? No. These Hackspace have got the documentation how to send programs on when you're flashing them as well. So you know, it might turn out to be strategic.
You could make it work with the software USB. That's what the board that we've got in the past today does.
Oh,
It
right.
actually does software USB for the bootloader.
Okay.
So you could do that with the shrimps actually.
Right.
You'd need a kind of
Oh,
USB kit.
I know what you're talking about. Yeah.
That's exactly it, yeah.
Yeah. I didn't know the name of that thing. But
Yeah.
USB ASD.
It'll be the
I think it's USB
It's
ASD.
basically the same code that you're using for the hit there. It's just you're doing the program around the keyboard.
Yes. So if you're interested in talking about that, grab me afterwards because there's some trade-offs there. So thank you. All right. Catch you later.
Very much, Kevin.